Hello everybody, welcome to Acids and Bases. We've got a question here. A household vinegar contains 4.52% of ethanoic acid or acetic acid CH3COOH by volume. So it contains a fraction of 4.52 of the ethanoic acid by volume. You've got 1.2 gram of an impure sample of calcium carbonate, right? A sample with impurities, not all of it is calcium carbonate, that is added to 25 cubic centimeter of the household vinegar. The same household vinegar that you were told that it contains 4.52% of ethanoic acid by volume. So on completion of the reaction, the excess ethanoic acid in the household vinegar is neutralized by sodium hydroxide solution. All right. So this means that ethanoic acid, you've got more of it. All right. It's in excess within the solution. All right. So basically, this amount that is in excess is neutralized by 14.5 sodium hydroxide solution of this concentration. You are given a balanced equation for this reaction, and it's important, guys, to be able to balance your equations because it could affect a lot. 7.2.1, calculate the number of moles of the unreacted ethanoic acid. So basically here they are looking for the amount of ethanoic acid which was actually neutralized because it was the excess amount which did not react. So in order for us to find this, we need to find the number of moles of sodium hydroxide which actually neutralized the excess. Then from there, we are going to find the number of moles of ethanoic acid. The unreacted one is the excess amount, okay? So we've got volume multiplied by concentration. So the volume is 14.5. That is cubic centimeter. It's the same as milliliter. So to convert that to decimeter cubed or liters is times 10 to the negative 3 decimeter cubed. You multiply this by the concentration. The concentration is 1 mole per decimeter cubed, okay? And then from here, you are going to get 14.5 divided by 1,000. You are getting 0.0145 what? Moles of NaOH. This is the NaOH. This is the sodium hydroxide that neutralized the excess ethanoic acid. So now you need to find the excess ethanoic acid or the ethanoic acid which was unreacted, okay? And then using the molar ratio, you've got 1:1 molar ratio between ethanoic acid and what? And sodium hydroxide. Okay? So as a result, the number of moles of sodium hydroxide the number of moles of acetic acid which did not react, all right, is actually 0.0145 moles CH3COOH. This is the unreacted. Okay, great stuff. So this was the amount that was eventually neutralized. Okay, now let's go to the second question. Calcium carbonate reacts with ethanoic acid according to the following balanced equation. Once again, balanced equations are very significant here. Calculate the percentage of the calcium carbonate in the impure sample. The impure sample is what? 1.2 gram. Okay. If 1 centimeter cubed of household vinegar has got a mass of 1 gram. This is very important. Number one, when we are looking at 7.2.2, we gotta understand the first part. It says 4.52% of ethanoic acid by volume. That is what the household vinegar contains. So now, this calcium carbonate was added to 25 cubic centimeters. But now we should consider this fraction over there. So basically the volume of what? In cubic centimeter of the household vinegar there, that volume is going to be what? The volume of ethanoic acid in the household vinegar is going to be 25. Remember, cubic centimeter and milliliter is the same thing. Let me just say cubic centimeters, okay? So it's going to be a fraction, which is 4.52 divided by 100, okay? It's going to be that fraction. All right, and then 25 times 4.52 divided by 100, and then from here we're going to get a volume of 1.13 cubic centimeters. What is that volume for? That is the volume of CH3COOH, which is what? Which is contained in the household vinegar, as you guys are seeing there. Now, this is very important. Listen here. They said, if the impure sample, if 1 cubic centimeter of household vinegar is 1 gram, okay, that is like giving you the density. So from that density, you need to find the mass in gram of what? CH3COOH, okay? So you already have the volume there, 1.13 cubic centimeter. They said what? 1 gram is actually 1 cubic centimeter, okay? And then you get the mass there, 1.13 grams of the household vinegar, all right? And then you guys continue. So from here, you are going to find the number of moles of acetic acid, the initial amount, okay? Then the initial amount in moles is going to be the mass divided by the molar mass. So the mass, you've already calculated it as 1.13 grams. And then the molar mass there, let's see. So 2 times 12 for carbon plus 4 times 1 for hydrogen plus 2 times 16 for those 2 hydrogens there. And then you get, let's see, that is 0.0188333 moles of what? Of CH3COOH. These are the initial amount in moles, okay? So basically, now that you guys have found that, you need to find out how much now that you have found out, you need to find out the number of moles of CH3COOH from the initial, basically how much actually reacted, okay? So in order for you to do that, remember, what is the initial amount? The initial amount is what? Is the amount that would have reacted plus the excess amount, okay? The amount that is in excess or did not react. So now to find the number of moles that reacted, it's going to be what? Your initial amount minus minus the number of moles or the amount in moles which were excess. All right. Then if you look over here, your initial amount is 0.018833 whatever, minus the excess amount is the one that you calculated here, the amount which did not react, 0.0145, that one 0.0145, and then you might want to save that value in the calculator. Okay, where's my calculator? Okay, so 0.0, okay, rather let me say answer, I already have it here, minus 0.0145, and then I got the number of moles of CH3COOH which reacted is actually equals to 0.004 moles. Okay, now with this amount you need to find out how much of this calcium carbonate, how much did it react with? So you need to find the number of moles of calcium carbonate which actually reacted. All right. Remember, you've got an impure sample. So now you're trying to find the pure amount in moles. Okay. So this is what you are finding. This reacted with calcium carbonate. So now to find how much did not react, you're going to use the molar ratio. 0.004333 moles of CH3COOH times. You look into your equation. All right. For every 1 mole of acetic acid, you've got, for every 1 mole of calcium carbonate, you've got 2 moles of acetic acid. So that simply means for every 1 mole of calcium carbonate, you've got 2 moles of acetic acid, right? Okay, cool. You don't have to do it like this. You could do it, your own way. So that's basically dividing that by half. Okay, dividing that by 2, I mean. Okay, and then you've got 0.0021666667 moles of CaCO3 which actually reacted. So this is the pure amount. All right, remember, within the 1.2 gram, this is the pure amount, but now we just need to find that amount in mass, CaCO3 which actually reacted, is equals to what? So that is going to be the number of moles which you have just calculated times the molar mass. Okay, so basically let's look into that. So the number of moles is what? 0.00216667. Okay, and then the molar mass of calcium carbonate, I calculated it to be 100. All right, and then after you get this times 100, and then I get 0.216667 grams of calcium carbonate. So this is the pure amount in the household vinegar. All right, so now the percentage of calcium carbonate, what are they looking for? The percentage of the calcium carbonate in the impure amount. So it's going to be the pure amount in grams divided by the impure amount in grams. So we've got 0.21666 grams divided by 1.2 times 100. and then that is divided by 1.2 times 100, then that is 18.056%.